Okay, hi. Okay, so I will release out all the steps. So now, okay, what's the mean? I will explain what's the mean by step 1. Step 1 is rewrite the equation in terms of Laplace transform. So I will explain how, or I will show what is the mean of rewrite. Okay. So before this, we learn the Laplace transform for the given function ft. Okay, ft you can refer to a table which either is a polynomial, either is exponential, and so on. So the answer will be fs. Okay, using table you find the column ft and then you get the answer fs. So this is the Laplace transform for ft, and then you get fs. So now it's a new thing for you is you want to find the Laplace transform for f prime t, f prime. So it's a derivative. Okay, it's a derivative f prime t. So what's the answer here? Okay, so Laplace transform for f prime t is given by as fs minus f0. Okay, as fs minus f0. So it's already fixed. Okay, actually there's the proof or the steps how we get this one, but for you I think you just using this one. Okay, I mean you just take it and we apply. Okay, no need to know, no need, but for because we have a kekangan kat sini kan, so you just accept it. I mean the Laplace transform for f prime is given by this. Okay, and then the Laplace transform for f double prime, okay, means that this second derivative f double prime is given by s square fs minus s f0 minus f prime 0. Okay, s square fs minus fs0 minus f prime 0. So this is for second order or second derivative. So the next one is for third order, f triple prime. So it will be given by s cube, okay, fs minus s square f0 minus s f prime 0 minus f double prime 0. Okay, so basically our for our syllabus we just cover until second order. Okay, so hopefully that you can memorize these two lah. Okay, memorize these two. Alright. Okay, so now I will show you. Okay, I will show or I will explain to you how to solve. Okay, by using through example. Okay, so example 1. Okay, example 1. The question asks you to solve the equation dx dt minus 2x equal to 4, given that at t equal to 0, x equal to 1. Okay, so I believe that all of you seems like this question is similar. I mean this question is something that you familiar. Okay, you familiar because this is a standard equation for differential equation. Solve the equation dx dt blah 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 given that blah blah blah. Okay, so I mean you already see this question in chapter 2. But for chapter 2, you learn different method. You learn about what we call the undetermined coefficient and also variation parameter. So they have you already learned two methods before this. So in this chapter, Laplace transform, they have another one method in Laplace transform to solve this equation. Okay, so this is the new thing for you. I mean this is the new method for you to learn, okay, to apply to solve the initial value problem. Okay, alright. Okay, so this is the question, and clearly that you can see here they have initial condition. So initial condition is given by this statement, or we can write it in terms of mathematics. So it means this. Okay, from this statement is equal to this. Okay, means that t0 x equal to 1. Okay, alright. Okay, we want to solve this one. We want to solve this equation. Okay, you need to refer back to your steps. Okay, refer back to your steps. Okay, step number 1. Okay, step number 1 says that you need to rewrite this equation. Okay, you need to rewrite this equation in terms of Laplace transform. So what we can do is, the first step, so you just put the L here. Okay, dx dt minus 2x equal to 4. So just put the L, and then overall here, inside here, you just rewrite back. Okay, so next, by using linearity properties, we will break it into one by one. Okay, first I break the dx dt. After that, I will break it the Laplace transform for 2x, and then I will break it the Laplace transform for 4. Okay. Okay, alright. So here you can see they have a 2 here. So again, apply the linearity properties. Okay, before that, can you see that this is dx dt? So we want to change the notation. I mean, we don't want to write dx dt. We want to write it in terms of x prime t. Okay, these two is equivalent. Okay, benda yang sama just saya tukar cara tulis dia. So instead of we write dx dt, we write it in terms of x prime t. Okay, then for this part, they have 2 here. So by using or by apply the linearity properties, you take out 2. So inside here you have x, and this x is x t. Okay, because we using the variable t here. So x prime t, so means that this is x t. Okay, the next one, the last one is the Laplace transform 4. Okay, what's the answer here? You can get the answer here. Laplace transform 4 is equal to 4 over s. Okay, you can using your table. Okay, saya tak nak ulang banyak kali, so you just using your table. So you will get your answer here for over s. Okay, now, okay, we are still in step number 1. Okay, we didn't finish yet. Okay, step number 1. Next is substitute this and this. We don't want to have x prime t, x t, and so on. We want to substitute with fs and fs or ss. Okay, we don't want to have t. Okay, so x prime t. Okay, just now I show you f prime. So actually, the equation can use any alphabet. Okay, it can use f, it can use x, it can use y, and so on. So what we do, this is the general one. So if here is f1, so we use the capital F here. If here is x, so means that we use capital X. So just using this one. So the first the first order. So you just replace with s, x, s minus x 0. Okay, Laplace transform for x prime is given by s, x minus x 0. So minus 2. Okay, how about this one? xt. So you refer to this one, ft. So ft you get the capital Fs. So means that here is capital Xs. Alright, okay, then the last one here is 4 over s. Okay, so finish. Okay, step number 1 is done. Okay, so now we proceed to step number 2. Okay, proceed to step number 2. Okay, step number 2 is insert